Hess's law states that it is possible to add two or more thermochemical equations to produce a final equation for a reaction, and the sum of the enthalpy changes for the individual reactions is the enthalpy change for the final reaction. So when solving this reaction, for example, you would first look for the two unique, or the only unique compound in this first equation that isn't in this equation, but within this equation. Okay, so here, in this case, it would be BC, or yes, it would be BCl here, is similar to this, and it's not in any other equation. So you would look at how you would make 2 BCl into this. So here, you obviously need to multiply this equation by 2, but since this is a product, you would need to switch it. So you would need to flip this equation, and that would require you to move H3BO and HCl to the beginning and this to the end. So here's how it would look like. You're multiplying the whole equation by 2, so you would write 2H3BO3 plus 6HCl, because 3 times 2 equals 6, and then it yields, this is whenever you would put that equation, that unique compound, into this reaction, which would be 2BCl3 plus 6, because 2 times 3, H2O, and the specific heat would also be multiplied by 2, so that should equal, you would multiply negative 112.5 times 2, and that should equal positive 100, or no, that would equal 225. And the reason why it's a positive number now is because you flipped it, and that also switches the signs. So this is 225. Now returning back to the other equation, you would work on the next one and find the unique compound for this equation that isn't in the others. And this one looks like it has this compound and this compound, but since they're in the same spot, this would mean that this equation is fine and it works. So you would just write it down here, come back down here, and write that same equation down. So it'd be B2H6 plus 6H2O yields 2H3BO3 plus 6H2, and the specific, or the enthalpy change would be negative 493.4. And then returning back to that last equation, it's the unique one for this one would be Cl2. But since this is 1/2, you would have to multiply this entire equation by 12 to equal it to 6 Cl2. So returning back to these, you would multiply 1/2 times 12 would equal 6H2 plus 6Cl2 yields 6HCl. Now, you would also multiply this by 12, so that would equal negative 1, or it would equal negative 1107.6. And after that, you would just basically add them all together. So you separate the reactants and products and put the reactants first. So that would be, you would get 2H3BO3 plus 6HCl, and then come back down here, and that would be plus B2H6 plus 6H2O, and come down here, and that would be plus 6H2 plus 6Cl2 yields, and then you return to these, and that would be plus, or 2BCl 2H3 plus 6H2O plus 2H3BO3 plus 6H2 and plus 6HCl. At this point, you need to start canceling out anything that's similar from each side. So here we have 2H3BO on the reactant side and the same compound on the product side. So you just cross those two out and basically do anything, the same thing with the other compounds. So here, this isn't on the other side, so this one should be fine. And you keep that. Same goes for this. And this one would be crossed out here. And you cross that out, and then this gets crossed out too. And you're left with these two. Now, you may be thinking, why is there 6 HCl here and 12 HCl here? Sorry, that should be 12. Well, in that case, since you've got the same compound on each side, you would need to subtract. Now, if it were another case where it's on the same side, you would just add them together, and it would equal 18 instead. But since this is on opposite ends, you would just subtract. So 12 minus 6 equals 6, of course. And then this should end with you having B2H6 plus 6Cl2 yields 2BCl3 plus 6HCl. And as you can see up here, it's the same exact reaction. So you know you got everything right. And to find the enthalpy here, you would just add all of these changes over here. And the sum of that should equal the enthalpy change. And so this would be negative 1,376 kilojoules, which is the enthalpy change for this reaction.